turning to our last presentation by Ingvild Losnegard from Bergen, Norway. And her talk is Precision Diagnostics in Diabetes, Unraveling the Disease Causality of HNF1B Coding Variants in two large Norwegian diabetes registries. Ingvild.
Yes, thank you. My name is Ingvild, and I'm currently working on functional characterization of 14 HNF1 beta variants identified in patients recruited to two Norwegian diabetes registries, generating data for the variant interpretation process and hopefully assisting in a precise diagnosis and tailored treatment for the patients. So pathogenic variants found in the HNF1 beta gene cause MODY5, which is a developmental and multi-system disorder with a broad phenotypic variation, including abnormalities in kidneys, liver, pancreas, and genital tract, as well as diabetes. So in this study, the aim is to functionally investigate these 14 HNF1 beta variants and to correlate the functional findings with the clinical characteristics of the variant carriers. So over to the functional setup. This figure gives an overview of the general workflow and the functional assay used in this study. And the functional effect of the HNF1 beta variants is measured in terms of transcriptional activity, protein expression levels, subcellular localization, and DNA binding ability. The functional data, together with the clinical information, forms the basis for variant interpretation, and the variants are classified using the ACMG guidelines. Figure A here displays the results of the transcriptional activity. And here we see that 7 variants demonstrate significantly reduced transcriptional activity of around or below 30% compared to the wild type of 100%. 2 missense variants also show significantly reduced activity, averaging around 50%, whereas the remaining 5 variants have similar performances to the wild type and synonymous controls. In the subcellular localization assay shown in figure B, all variants demonstrated close to 100% localization in the nucleus, except for 3 variants which were undetectable, most likely due to degradation by nonsense-mediated decay. In the DNA binding analysis, only the variants located in the DNA binding domain were included. And as we can see in figure C, 7 variants demonstrate significantly reduced DNA binding ability of around or below 40% compared to the wild type. So the functional data and the clinical information of the variant carriers are summarized in this table. And what we can really see from this table is that the functional data corresponds very well with the clinical information for most of the variants. This has allowed us to classify 8 variants as pathogenic, 1 variant as likely pathogenic, 3 as variants of unknown significance, and 2 variants as likely benign. Thank you.
Well, thank you very much. These are good examples in how to approach really precision medicine and diabetes, particularly for MODY and the various mutations that exist within that space. So we're out of time. Thank you, Ingvild. Very nice work. And I'm going to turn this back to our moderators. I want to thank everyone for being with us this morning, this evening, or whatever time of day it is in your part of the world. And back to you, John and Christine. I want to thank all the speakers for their exciting data to be presented here at this meeting. John, Christine, back to you.
Well, actually, Bob, thank you very much for that and for doing a very good job of keeping the time. That really concludes our sessions for today. And I want to thank everybody who's taken part, those fantastic poster presentations and the great plenary talks we had earlier on. That's it for today. We've deliberately kept this meeting 3 hours duration so that allows people in all the time zones to take part. So I hope you enjoyed the sessions today, and please join us by logging on tomorrow. at 8 a.m. Eastern US time and all the other times. Thank you very much.